Hello, my name is Jenny Gardner and I'm an academic coach here at SNHU. Welcome to this guide on scatter plots and estimating Y values. Today we're going to talk about definitions first, then we'll go into scatter plots and a regression example. We'll use Excel, and finally we'll talk about interpreting these items from that example. So here are definitions. Here we go. First, we have to think about correlation and what it means. Correlation is all about the relationship between two variables. Variables can be many different things, and anyone can propose that two things are linked, related, correlated, but we have to see if they actually are. So a correlation would show a relationship between the explanatory, that would be our X variable, and the response, the Y variables. So we're trying to see, is Y responding to changes in X, our explanation? So X, explanation, explanatory, Y, response, and it's all about change. And speaking of change, we can talk about the slope. Sometimes people think of slope as the angle of a line when you look at the graph. So an XY graph looks like this, where this line is the X line and this line is the Y line. And there might be some dots along the way representing all of our real data and real information. But the slope is the angle of the line that represents all the data, the average of all the data in between. And the angle of this line is the slope. But thinking not just of the drawing and not just of how a graph looks and not just of the line itself, the slope can also just be represented with a variable, a letter. And we see that it could be represented as beta 1, B1, or M for our slope. And the slope is all about the change. It's showing you that when X changes by 1, Y has some change to it too. And as X changes and gets bigger this way, as X goes up by 1 each time, etc., we want to know, well, how far is Y going up? What is Y at this point here? And what is Y at this point here? And how much is it going up each time that X is changing? Well, that's the slope. Every time X changes, Y will increase the amount of the slope. So it's the angle that can be created between 2 points, but in total, it's the angle of the whole line that represents the change. Y-intercept is a part of this as well. The y-intercept is where the line intersects with the y-axis. So over here, right here on my drawing, I'm drawing it in red, right there is the y-intercept. And the y-intercept happens when x is 0, but not when y is 0 necessarily. It can be any number for y. If the line was up here, x would still be 0, but the y-intercept would now be all the way up here. So wherever that line is hitting the y-axis and crashing into it, that's when we know what the y-intercept will be. And that always happens when x is 0. So thinking about that, these are some of the letters that notate it. We have beta 0, B0, or just B, and this will be in that linear equation that we'll see in a moment. But thinking about it logically and what it means and what it tells you that when x, whatever x might be, when it is 0, what value is y? Y would be the y-intercept. So we can see how that works in the equation as well. So how do these slope and intercept values fit into the prediction equation? Just by putting them together like this. The slope is next to x being multiplied by x. See how they're next to each other here like this? That indicates multiplication. And then you're adding the intercept. So you've got the slope times x plus the intercept. So if all these letters are confusing or the variables are confusing, you can write it as slope times x plus our y-intercept. And the whole reason we do that is to predict y. So this EY over here just means predict what y is. What is our expected value for y, our expected y? And so our predicted y is going to equal the slope times x plus the intercept. Now you'll notice that E with y in parentheses means expected y, and the y with the little triangle on top is y hat, or predicted y, but they have the same values, the same equation, and they mean the same thing. We're looking at how it's going to work and how we're going to predict y. You can use them the same way. So now let's put it all together with an example. The regression line equation, it can be called so many different things, and I have some of these names up top. We have best fit line, regression equation, regression line equation, slope-intercept equation, prediction line equation, and there might be some other names along the way. The principle of it is the same, but as we get into different fields, we're going to see that they're used to do different things. So the best fit line might work for something if you're looking at a business equation. Regression equation might be something that you're doing with research and psychology research, etc. And when you're looking at all these different things and it applying to different fields, the names change. But they're all talking about this equation that we have right here. Y can be predicted by taking the slope times x plus the intercept. But it can only be predicted that way if it's correlated. So we have to decide if it's correlated first before we can predict. And we're going to do that visually today with a graph. But check out our other resources and other videos. You'll be looking for a correlation coefficient in the future to how to do that as well. So today we're going to talk about visually graphing this with a scatter plot. I have some data here, and you're welcome to pause and try this on your own as well. And you can type in these numbers, but I have them up in Excel, and we're going to go ahead and make the scatter plot, put the line into the scatter plot, and then from there we'll try and make our equation. All right, so you see I've already copied it over. We have these people who are working at this place. Then we have bonus sales that they made and the pay that they received. And we're going to kind of see what happens here. So I'm going to go up at the top to Insert. And I want to use this scatter plot here. But before I can do it, it's much easier if I've highlighted my two columns. So I need my two columns with my numbers. And I want them in the order of X and Y. So we have to decide which one's X and which one is Y. So remember, X is the explanation, the one we are using to predict. And so we're going to use the bonus sales as X to predict our pay, which is Y, because this is the one we wish to predict. Okay, so I'm going to keep them in this order. Highlight, just click and drag with my mouse, the two columns, two areas, and I don't go past the numbers. I only include the ones I need. And then up here, I'm going to pick my scatter plot. Right here, my lovely scatter plot. I'm going to change it, make it darker. I can make it in dark mode. I can make it blue if I wanted, whatever I wanted to do. I'm going to leave it in dark mode here. And now I have my scatter plot. Let's make it big for you guys. Then, now that I'm on here, at the top it says add chart element. You have to be clicked on the chart for this to work, but I'm going to add chart element and I'm going to put in a trend line. And I'm going to put in a linear one because that's what we're working with, linear correlation. So I'm going to put in a linear line here that puts in my average, my y equals slope times x plus intercept. That's the line. And now it's in there, good to go. And looking at this, we want to know, is it correlated? So pause for a second and think about that. Do you think this shows a strong, weak, Moderate correlation. What do you think? So I hope you paused and thought about it, but I would say this is a pretty strong correlation. Most of the dots, these are near the line, and the line is very angular. You want something that's at a diagonal line. If it's more straight across, there's not a lot of change occurring, but it does have a nice angle to it, a lot of change happening, and we can see that all of the lovely pieces of data, the dots, are close to the average line, so it's a pretty strong prediction here. We've got a good one going. So that's our lovely prediction line and our lovely graph and how to look at it visually. So let's head back over and see what else. Okay, so we also need to make this equation. Okay, so we want to make sure we know how to do that as well. So now that we have our scatter plot, we're just going to put that to the side a little bit. And up here, I'm going to go to my data tab. I'm going to go to data analysis. And if you don't have data analysis, go ahead and look up how to do that and get it because it's free. You can just search add in here and you would be able to add in the data analysis tool pack, which is the first one. So if I go to data analysis, I'm going to go down to regression. There's other things I can do on here, but I want to talk about the regression equation. So I'm going to go to regression. This will come up blank. So when it says input Y range, I'm going to have to click and drag my Y range, but just the numbers. And then the X range, click and drag my X range, just the numbers. Everything else doesn't need to be done unless you wanted to see what they were. But for what we need for slope and intercept, we're just going to do Y and X and hit OK. A lot of info here, right? But we're going to say we just need the top two and the bottom two. Top two and the bottom two. In general, those are the main ones that you need. As you continue on, you might get into some more difficult things and you might be using some of the hypothesis testing. But right now, when you're thinking about the future, you might need R and you might need R squared. Or in our case this time, we just need the intercept and the slope. So intercept, slope, that's what we need. The numbers are right here. So our slope is 85.38 and our intercept is 536.6. Let's look at what that means. Over here on the graph, I'm going to copy them over so we can see them together. Okay, so intercept is 536. So when x is 0 right here, we look up, and if this line kept going, it would intersect at 536 right here. Good, that's the starting place of our line. And then it says the slope, this one is the slope, is 85.38. So for every one increase, it's going up by 85.38. So from 1 to 2, 1 being here, 2 being here, it went up on this line about 85 and exactly 85.387931. So every time we go over, it's increasing by that slope. And we're going to use these numbers and really dive into what it means now. All right. So let's say that last equation was about a sales program that a business was having. And we used that data to really make sure it was following the sales program. And we see that we have this lovely equation created. And remember, it's slope times x plus the intercept. So that's how y is predicted. So we're going to interpret the slope. Remember, the slope is interpreted for every change. Change can be represented by a triangle. So every change in x, y will change by the slope. Now, what does that mean? That means that if x represented your sales, so remember that x was sales, and Y was your pay, then every time X changed by 1, every time you had an extra sale, your pay would increase by the slope, 85.39. So your pay goes up $85.39 based on the sales on average. And that's what the slope tells you. Let's look at the y-intercept. If we had 0 x's, that's what the y-intercept tells you. So when x is 0, y equals the intercept. So let's look at what that means. If I put it into the equation and I said I had 0 sales today, 85.39. Maybe I had 0 sales my entire check this time. Then I put in the 0 next to the slope because x is next to slope. But I still have to add the 536.60 for the equation. Okay, so to predict my pay, I would use this equation, put 0 in, and I would see 0 times 85.39 is 0. And then if I add my intercept, I end up with an estimated pay of $536.60 when I don't make any sales. And that makes sense because my pay is not going to be nothing if I don't have sales. I'll still get a base pay, but I'm not going to get any of that bonus. So I'm just going to stick with the fact that I'll get $536.60. Now the entire equation means that we can use this to predict any amount. Instead of this 0 I put in, we could put in any number that's within the numbers we measured. So I could check to see what happens if I have 2 sales, what happens if I have 4 sales, etc. I could see what's going to happen and predict what the pay would be. So if Bob was a new employee and he sold 4 bonus items, what is their predicted pay? Well, 85.39 times 4, and then we add in our intercept of 536.60. Take a second and try that out on a calculator and see what you get. Remember, you're taking 85.39 times 4, and then you're going to add in that 536.60. All right, hopefully you paused and got $878.16. That is what we predict that Bob's pay will be based on the sales program. Okay, so we predicted $878.16. That's what we predicted to happen. So 878.16 was the prediction. That's what we think the average pay for someone who does 4. The average for someone when X equals 4 is 878.16. But also, it might be different than that. So we see that Bob received 910 on his first check. He did not have the average. And that's because he's a real person, and real data is slightly different than the average, but it's close. So to figure out the residual, we would just say, well, is he above or below average? 910 minus 878.16. So real minus predicted, and we would see that 910 minus the 878.16 is going to be $31.84 above the average pay, a positive number because it's above average. So that's our residual. That's the difference between what he made and what the average said he would make. And so now that we know that, we know that something happened. Maybe Bob has different withdrawals from his check. Maybe he gets less taxes taken out. Maybe he doesn't have as many dependents, or maybe maybe there's another bonus program for some other items, or maybe there's a sign-on bonus of $31.84 for when you first join the company. Who knows what it is? We just know he's more this time, and that's something that happens. And we see that his pay is above the average, and he made an extra residual of 31.84. All right. Congratulations. Thank you for watching Academic Support Guide on scatter plots and estimating y today. Please read the video description for further resources, and way to go, you have conquered this video. Have a great day.